Today we are going to discuss about spanning tree. In spanning tree, it is a subgraph of an undirected connected graph which includes all the vertices of a graph with a minimum possible number of edges. If a vertex is missed, then it is not a spanning tree. Before we move on to spanning tree, we need to know the two types as one is undirected graph, another one is connected graph. In undirected graph, it's an example. It's a one example A, B, C, D. These are all the vertices, and then these lines are edges. Okay. In this structure, a to B or D, maybe it may be D to A. So it doesn't represent any directions. So it is we call it as a undirected graph. In connected graph, C is a center point and then C is connected to D and again A is C is connected to A and again C is connected to B. So it is we call it as a connected graph. And then in spanning tree, it is a subgraph of undirected graph. It includes all the vertices of a edges. And then if any vertex is missed out, it will not be considered as a spanning tree. And then if we need to calculate a number of spanning trees means by using the formula n to the power of n minus 2. So it's an example, it's a original graph A, B, D, C are vertices and the lines are edges. And these are all the possibilities to form a spanning tree. And then next one is a minimum spanning tree. In minimum spanning tree, it is also a spanning tree in which the sum of weight of the edges is minimum as possible. So in minimum spanning tree, if all the edges, we need to calculate the edges and uh, weightage of that edges. So if the edge value is minimum, so we call that graph as a minimum spanning tree. So these are all the applications of spanning tree and minimum spanning tree. And then in spanning tree, it works in routing protocols, clustering analysis, and civil network plannings too. And then in minimum spanning tree, it's used to identify the path of a map, and then it's used in a telecommunication networks, and it's also supply a networks and electrical grids to the networking protocols like that. And then next one, if we want to calculate a minimum spanning tree means we need to use two algorithms. One is Kruskal algorithm, another one is the Prim's algorithm. Here we will discuss about Kruskal algorithm. It is a minimum spanning tree algorithm that takes a graph as input and find the subset of edges of that graph, which it forms a tree that includes every vertex. It has a minimum sum of weight among all the trees. It can form a graph. So it's a definition of Kruskal's algorithm. And then how Kruskal's algorithms works means first sort all the edges with the weight values. Weight values means this is a weightage of the values 5, 4, 1, 2. These are all the weightages of the edges. So first we need to calculate, sort all the edges with low to high values. That means 1, 2, 3, 4 like that. And then next is take a edge with the lowest weight and it is add to a spanning tree. If it is forms a tree means we just stop the process and come out from the algorithm. So let's see one example. Here A, B, C, D, E, F are the vertices, and then here this blue lines are edges, and 4, 4, 2, 3, 2. These are the weightage values. Okay. With the help of these graph, we need to find out the Kruskal algorithm. So, in this example, first we need to, in step 1, we need to calculate the number of edges. So, here the number of edges is 8. 1, 2, 3, 4, 5, 6, 7, 8. So, we calculated. So, and then next one is we need to write all the vertex pairs. Vertex pairs means connected pairs. That means A to B, A to C, B to C, C to D, D to F, and again C to E, E to F. These are all the vertex pairs. So A to C is also a same weightage value, and then C to A is also having a same weightage value. So no need to write A to C, once again C to A. Just write any one. So A to B or C to A. This is step 2, and in step 3 we need to write all the vertex pairs in ascending order with the help of weightage value. So here so minimum weightage value is 2, no. Here B to C or C to E. These are all the minimum weightage value. So first just write B to C and C to E. Okay. And the next value is E to F. And next one is D to F. Third one is C to D. At last A to B, that is fourth weightage value, and then A to C, at last C to F. This is a this is the way we need to write vertex pairs in ascending order. With the help of this weightage value, we need to write is in ascending order. Okay, and then C. For in step two, I'm writing first lowest value, that is 2. In step 3, I am writing second weightage value, that is 2. In step 3, I am writing third weightage value. Okay, that is 3. Once again, the 3 is there, no. Here. 3 weightage values. So only I am writing 3. Okay. At last, next one here. In step 6, once again I am write 4 weightage values. That is fourth one. So it is our it doesn't form any full completed graph, no. So here is an empty one, and here is empty one, here is an empty one. If it is connected here, it forms a spanning tree. So before that, so only I didn't write last value, that is C to F. If I am putting C to F means the graph will be completed. So see here, if I am putting here this weightage value 4 means it is a completed, here that is here to here, and then here to here. So it forms a one graph, no. So when the graph is formed a full circle means it is not considered as a spanning tree. So at last, if all the vertex pair is completed, exit from the loop or exit from the algorithm. In last step, if a graph is formed fully, just stop the process and complete a Kruskal algorithm. So this is the basic steps in Kruskal algorithm. Thank you.